Assalamualaikum and greetings to all. We are still on chain rule. The last part of the chain rule is a little bit different from what we've done so far. Okay, I'm going to go straight to giving you an example. Okay, in the slide here you can see that we have W is equal to XYZ with X equals T cubed, Y equals T squared and Z equals T to the power 4. And we are asked to find, here you can see that we have ordinary derivative instead of partial derivative. We are asked to find dw dt. So that is ordinary derivative, not partial derivative. Okay, all right, let's solve this. Okay, so this is the last example, which is a bit different from what we've done so far. So again, I'm going to sketch a tree diagram. So we start with W. It says W is equal to XYZ. So we branch out to 3 branches, X, Y, and Z. And here it says X is equal to T cubed. So you can see that we only have one variable there, which is T. So X is a function of T. So one branch there. And W, excuse me, is equal to T squared. Again, only one variable. So branch out to one branch. T, and Z is also a function of T only. So we have T here. Now, when you look on the far right, you can see that we only have one variable. We have T, even though T is written 3 times here, but you can see that we only have one variable, which is T. So if we only have one variable, then when you differentiate, you get ordinary derivative instead of partial derivative. Okay, so here we only have one independent variable, but we have 3 intermediate variables. 3 intermediate variables, and of course W is the dependent variable. So when we want to find the derivative of W, it's not going to be partial derivative anymore, but it's going to be ordinary derivative. So we're going to use dw dt, just like in engineering math 1 or in high school. So we have ordinary derivative. Why? Because we only have one independent variable, even though we have 3 intermediate variables. Okay, all right, so when we want to find dw dt, we look again on the far right. We have 3 t's, which means we have to have sum of 3 terms. Okay, sum of 3 terms because we have 3 t's on the far right. Okay, now let's look at the first term. The first term, we start from W. We want to go to this T. It has to go through X first. Now from W to X, it has 3 branches. So when you differentiate W, it's going to be partial derivative, partial W, partial X, because here W is in terms of 3 variables, X, Y, and Z. Okay, so when you differentiate W with respect to X, it's going to be partial derivative, not ordinary derivative. But when you differentiate X with respect to T, because it only has one variable, the derivative would be ordinary derivative, dx dt, excuse me. Okay, now the second term, we want to go from W to this second T. It has to go through Y first. And again, here when you differentiate W with respect to Y, it has to be partial derivative, because W here is a function in terms of 3 variables, X, Y, and Z. So when you differentiate, you get partial derivative. But then when you differentiate Y, it's going to be ordinary derivative, because Y is in terms of 1 variable. So when you differentiate, you get ordinary derivative. And the last term, we have to go from W to this Z and then to T. So again, when you differentiate W with respect to Z, we have to use partial derivative. And then when you differentiate Z, it's going to be ordinary derivative, because Z is in terms of 1 variable. Okay, so now we're going to find all the terms. Okay, we need partial W, partial X. Okay, so this is our w. Oops. This is w. Differentiate w with respect to x. So we consider y and z as constant. So we have y, z. We also need dx dt. Oops. Dx dt. Differentiate x with respect to t. That would be 3t squared. Okay. Oh, missing something here. D. And this one is y. Okay, now we need partial w, partial y. Differentiate w here with respect to y. That will give us xz. Then we have dy dt, not partial, okay, because we only have one variable. So differentiate y with respect to t, we get 2t. And we also need partial w, partial z. Differentiate w with respect to z, we get xy. And the last term, dz dt, will give us 4t cubed. Okay, now we're going to put everything together. Partial w, partial x is yz. Dx dt is 3t squared. Partial w, partial y is xz. Dy dt is 2t. And partial w, partial z is xy. And dz dt is 4t cubed. Okay, now simplify this. We have 3yz t squared, 2xzt plus 4xyt cubed. Okay, and the last step is to replace the intermediate variables in terms of independent variable, which is t. So here we have yz, xz, and xy. So we're going to replace that in terms of t. So y is t squared, z is t to the power 4, and here we have 2x is t cubed, z is t to the power 4, and we still have t there, plus 4x, x is t cubed, excuse me, y is t squared, and we have t cubed. Oops. Right. Simplify that even further. I'm gonna write it here. So here we have 3. How many t's here? We have 8. Here we have 2. How many t's? 7, 8. And here we have 4. How many t's? We have 6, 7, 8. Simplify that. We have 3 plus 2, which is a 5. Then we have 9t to the power of 8. Okay, so that is the answer. Finding dy dt by using by using the chain rule. And of course we can obtain this without using the chain rule very easily. All right, yeah, that's it for today. Thank you.